Okay, we will go through some important points in the class 12 physics chapter 8 electromagnetic waves. See here, the time varying electric field generates a magnetic field. Speed of light, this may 3 into 10 power 8 meter per second. Light is an electromagnetic wave. These are the wavelength of gamma rays to radio waves. See, this is the displacement current which is missing in the Ampere's circuital law. The current carried by conductors due to the flow of charges is called the conduction current. The current given in the equation is a this is 8.4. This is the new term. This is nothing but the displacement current, and is due to changing electric field. The changing electric field, that is electric displacement, it is therefore called the displacement current, okay, or Maxwell's displacement current. This is the new term. Maxwell found this displacement current in addition to the conduction current. Conduction current and the displacement current. So the total current equal to conduction current plus displacement current. This is the displacement current and this is the conduction current. So conduction displacement current is related to the rate of change of the electric field, phi E. That is the rate of change of electric field. Outside the capacitor plates we have only conduction current and no displacement current. On the other hand, inside the capacitor there is no conduction current and there is only displacement current. That is important. Inside the capacitor plates there is only displacement current, whereas outside the plates in the wire there is only conduction current. So the Maxwell's Ampere-Maxwell law, which includes both conduction current and displacement current. This is the displacement current, this is the conduction current. So these are the laws. See here this is surface integral dA we are using here, but here dl, this is path integral dl and dA. This difference should be there. Okay. This is a line integral or a path integral. This is the area, surface integral. So here in this we are converting farad to nanofarad, mega ohms to ohms. Accelerated charges radiate electromagnetic waves. The frequency of the electromagnetic wave naturally equals the frequency of the oscillation of the charge. This is the electric field is directed perpendicular to the plates inside the capacitor. This is a electromagnetic wave electric field, magnetic field, both are perpendicular to each other, and they are also perpendicular to the direction of the propagation. Okay, all the three are perpendicular. Electric field, magnetic field, and the direction of the propagation, all are perpendicular. That is, one will be in x, one will be in the y, one will be on the z. This is the general formula electromagnetic wave, where k is the magnitude, z is the direction. This is how k is related to the lambda. You can also write k equal to omega by c, because omega equal to 2 pi v. If you multiply and divide by v, 2 pi v omega, lambda v is c. Okay, v is the frequency here. I am talking about the frequency v. K is the magnitude of the. This is the velocity of light related to the permittivity of this free space. Okay, this is important. C equal to 1 by square root of mu naught epsilon. This is how electric and magnetic fields are related. Magnetic field equal to electric field divided by velocity of light. The velocity of light depends on the electric and magnetic properties of the medium. Based on this, they are saying, we shall see in the next chapter the refractive index of the medium with respect to other is equal to the ratio of the velocities. Okay, velocity and the refractive index. This is radiation pressure. Since it carries the momentum, the electromagnetic wave also exerts a pressure, that is called radiation pressure. Electromagnetic waves also have a pressure, radiation pressure. Momentum equal to the energy from the EM wave divided by the velocity of light. U, energy from the EM wave, electromagnetic wave. See, E is in the J, that is y direction, and is traveling in the x direction. That means P should be on the k direction. That is, it's traveling the x direction. E is in the y direction. That means this should be on the k. That is B should be on the k direction. That is z. All three are perpendicular. This is using that general formula kx minus wt, linear to angular, lambda to wavelength. Okay, half of the intensity is provided by the electric field and half by the magnetic field. Okay, when you say the electromagnetic wave, half of these waves intensity is contributed by electric field and half in magnetic field. Okay, the power. So these are the various spectrum, gamma rays, X rays, and the wavelength range of that wavelength. Okay, this is the visible wavelength. Okay, visible spectrum from this wavelength to this wavelength in the visible spectrum. Radio waves. These are the microwaves of the short wavelength with the frequencies in this range, gigahertz range. The frequency of the microwave is selected to match the resonant frequency of the water molecule, so that the energy from the waves is transferred efficiently to the kinetic energy of the molecule. Okay, microwave. If water receives the microwave of this frequency, its molecules absorb the radiation, which is equivalent to heating of the water. These molecules share the energy with the neighboring food molecules, heating of the food. Okay, this is how microwave oven works. Visible rays. Gamma rays, they lie in the upper frequency of the electromagnetic spectrum. Wavelength range protection detection. Radio. Microwave, infrared light, ultraviolet, X-rays, gamma rays. Displacement current. This is the velocity of light is related to the mu naught and epsilon naught. Mu is the permittivity of the medium and epsilon is the permittivity. Permeability mu, this is permittivity. Okay, exercise figure 8.6. Made up of shows a capacitor made up of two circular plates, each of radius 12 cm, separated by 5 cm. The capacitor is being charged by the external source not shown in the figure. The charging current is constant, equal to the 0.15 amps. Calculate the capacitance and the rate of change of the potential difference between the plates. First we calculate the capacitance, rate of change of potential. Distance between the plates they are given, i.e. capacitance equal to the epsilon naught, that is permittivity of the into A divided by D. A is the area, that is the circular plates, pi r square. Okay, this is the area. This is the permittivity of this free space, 8.85 in 10 power minus 12. This is the area. Distance between the plates. We are converting into the meter, centimeter to the meter. So after that you will get the capacitance. Okay. Now Q equal to C, we differentiate with respect to time, then you will get this. This is nothing but the current, that is 0.15 ampere. dq by dt is nothing but the current. Okay. So now rate of change of potential they are asking. Okay, that is dv by dt equal to I by C. I current by C. Okay, so this is the rate of change of potential. Obtain the displacement current across the place. Okay, this is the displacement current. Id equal to epsilon naught and dq by dt, d pi by dt, that is rate of change of the electric field. Q pi equal to q by epsilon naught as per Gauss's law. So you substitute this q by epsilon naught. This epsilon naught will cancel out. Dq by dt, that is nothing but the current, conduction current. So the displacement current is equal to the conduction current. Here this AC source is Kirchhoff's first law. Junction rule valid and each plates of the capacitor explained. Yes, it is applicable. So the total current is displacement current plus conduction current. So the current coming into a junction is equal to the currents flowing out of the junction. That is that Ampere Kirchhoff's law. Parallel plate capacitor is made up of circular plates of radius. Here R they are given as a capacitance of 100 picofarad. The capacitor is connected to the AC source with the angular frequency W. What is the RMS value of the conduction current, they are asking. Current equal to voltage divided by the capacitance. Xc equal to 1 by Wc. So now if you substitute for this Xc, I equal to V by Xc, V by 1 by omega c. That means it will go up, then V voltage into angular frequency into capacitance, that is the current. Okay, this is the current. Is conduction current equal to the displacement current? Yes, we already seen in the previous, when connected to the AC source, what happens. Yes, from the previous one. See here, this displacement current equal to the conduction current, dq by dt, that is the I for the AC source. From question number 1. Determine the amplitude of the magnetic field at a point 3 centimeter from the axis between the plate. 3 centimeter, you should convert to the meter. 3 centimeter 0.03 meter. B naught mu naught d I naught 2 pi r square. R is given. Mu naught, permittivity of this 4 pi into permeability 4 pi into 10 power minus 7. D, this value. I naught that is here. See, we have to find the peak value of the I naught. Peak value equal to square root 2 into RMS value. Okay, so root 2 into RMS value. RMS value from the above. This one. Then after that you'll get this V naught. What visible quantity is same for X-rays wavelength, red light of this wavelength, radio wave? See, all the waves travel at the same speed. That is, see, velocity of light equal to wavelength in the frequency. Okay, the different wavelength, they will adjust the frequency. The velocity of light will be same. The speed, X-rays and the red light as well as these all velocity will be same. C equal to lambda into frequency. C equal to lambda into frequency. This will be constant. So for various lambda, this will vary. A plane electromagnetic wave travels in a vacuum along this direction, Z direction. What can you say about the direction of the electric and magnetic field vectors? They will be perpendicular to the direction of the propagation. Okay, the frequency of the wave, frequency, what it is? Wavelength. Okay, frequency wavelength C equal to wavelength equal to c by frequency, that is velocity of light in vacuum divided by frequency, c equal to lambda v. In the z direction, electric magnetic field will be perpendicular this, it will they are in the xy direction, xy plane. Frequency equal to this much. Find the lambda using this equation. C equal to the velocity of light in vacuum, lambda into frequency. Lambda equal to this way, okay. A radio can tune in any station between this. What is the corresponding wavelength band? Okay, from the frequency you have to find the wavelength, then that is the range of the wavelength. Okay, for lambda 1 equal to lambda 2, that can be found from this using frequency. What is the wavelength? Okay, so the range of wavelength is this. A charged particle oscillates about its mean equilibrium position with the frequency. What is the frequency? Okay, so it is oscillating from the mean equilibrium position. That means this frequency is same as the EM wave frequency. The ambient of the magnetic field part of the harmonic electromagnetic. Okay, given magnetic field, what is the ambient electric field? Okay, we have to use this electric and magnetic field related to the velocity of light. See, this is how they related magnetic field equal to electric field divided by the velocity of light. They were given magnetic field, electric field equal to C into magnetic field, 3 into 10 power 8. Okay, this is the the electric field, Newton per coulomb. Suppose that the electric field of amplitude of the electromagnetic E naught given with the frequency determine this the other value. They are in the general form of the equation. These are the given thing, okay. E naught, B naught equal to this divided by the velocity of light from the above formula. So we will get the B naught, E naught, B naught. From frequency you can find the angular frequency. This is linear frequency, angular frequency 2 pi V. 2 into pi into, okay, this is the angular frequency. K equal to already shown in the book, okay, 2 pi by lambda, then it will become omega by C. If you multiply 2 pi by lambda above V and below also, lambda V is C, 2 pi V is omega. So this is how you will get this. Lambda equal to C by V. So if you assume one of the direction of the magnetic field or electric field, the other will be perpendicular to that direction, okay. So now we are assuming this on the y direction, okay, this is on the z direction. The terminology of different parts of the electromagnetic is given in the text. Use the formula E equal to hv, that is Planck's constant in the frequency of the light, the energy of the quantum of radiation of the photon obtained the photon energy, okay, ev. So E equal to hv, then frequency from this is, so it is velocity of light divided by the lambda. C equal to lambda v, from that formula we are finding this, okay. Then after substitution you will get this. If you substitute for different lambda values, different wavelength, you will get the value in electron volt energy. So how to convert a joule into electron volt? 1 joule equal to 1.6 in 10 power minus 19 electron volt. Okay, this part here to conversion, this is the conversion factor. So if you these are the electron volts energy for the various wavelength. In a plane electromagnetic, the electric field oscillates. Sinusoidally, the electric field oscillates. Okay, the amplitude. What is the wavelength of the wave? This is the wavelength. Okay. Velocity of light in a vacuum divided by the frequency wavelength. B naught equal to E naught by C. Okay, they already know E equal to CV. C equal to 1 by mu naught epsilon naught. This is also given in the book. Using that formula here, you square E square equal to this root will cancel when you square. Okay, and this is equal to the electrical energy of the component. This is equal to the average magnetic energy of this. Average energy density of E, average energy density of B. Okay, average energy density of E is equal to the average energy density. If you substitute the value, you will find these two are equal. Okay.